In this video, we want to review that why ANOVA table, which we had in the previous video, right? Why ANOVA table is important in our regression models. Where do we use it? And then we're going to review the hypothesis testing for the simple linear regression models. Generally speaking, we have, if you go and review chapter, I think it's in chapter 8. No, it's in chapter 11. When you are looking at the chapter 11 of the CHE 220, like second year stat, you will see that we have, for the hypothesis testing of the simple linear regressions, we have three different tests, that like three different variables that we consider, like we would do the test on it. I'm gonna quickly write it down here for you, and then we are gonna go to the notes. So we said that our model is y equal to the ax plus b, right? When you go and look at the, like, if you go and review the chapters over there, you will see that over there we use the beta null and beta 1. It doesn't matter, as long as we know that, for example, with this one we mean the intercept, and with this one we are looking for the slope of our line, it's fine. So what are we going to do? We are going to, with the least square method, we will find out A estimate and the B estimate, right, for our model. So we would say our Y estimate, our regression line, it's going to be equal to the A estimate times X plus B estimate. That's going to be our regression line. So when we are working with the hypothesis test for this one, I said we have three tests. The first one, so I'm going to write down hypothesis testing. On simple linear regression model. So the first one is that we're gonna see that if our B estimate, it's equal to the B that we have for the like from the population, for the real B that we would have. So the first one is that we are gonna test to see that if our B estimate, right? Test to see that if B estimate is equal to the B that we have for the population. I can write it down in a H null model as well. I would say H null is equal to B estimate is equal to the B, like the B that we had. You can name this B as B null as well, like B of the observations. And then we would have, like, that's the first one. Let's say the first category. The second one is the time that we want to test our A, like the intercept, and we would say H null is equal to the A estimate is equal to A. And then for all of this, we can say, let me see, yeah, it's visible. So we can say when H null is like this, H1 is going to be B estimate is not equal to the B. And here H1, B estimate, sorry, A estimate is not equal to A. So that's the first two hypothesis testing that we had over there. The third one, which is the most important one, is that when we want to test to make sure that at least we have one of the slopes that they're not equal to 0. It's like, in fact, I say one of the slopes because we have the same kind of testing when we have more than one independent variable. So when we are working with the multiple linear regressions as well. So it's not that this is going to be for, it's not just for single linear regression model. It's going to be, it can be for the multiple as well, regression models as well. So when we have like a few X, we need at least one of the slopes not to be equal to 0, to make sure that our model, there is a correlation between Y and X, right? Because consider, if I have my like A estimate, if it's equal to 0 in this simple model, in that case, I don't have any, like, my model doesn't show any relation between Y and X. So we call this one overall significance of the regression. So the test is the significance of the regression test. So this third one, we call it overall significance of the regression. And I name it, we would write it down like this. The third one, H null, says that A estimate is equal to 0, and H1 says that A estimate is not equal to 0. So 0 comes to the picture when we are working with this one. So this one, the third one, we name it overall. You can, when I'm showing you the lecture notes, you're going to see that as well. But we name it overall significance of regression test. Now let's go to the, by having this review, like quick review, now let's go and look at the lecture notes. Okay, so here you can see that it's written that we are using the overall significance of the regression. So for each of these tests that I wrote down, like I showed you here, we have different test statistic. So for this one, now we are talking about the third one. The third one is very important. We use it a lot in the experimental design or design of experiment and surface modeling, which is the same as optimization, right? A kind of optimization later. But overall significance of the regression, that's the name of it. So for a simple straight line, this is equivalent to testing the slope against 0. So it would be A is equal to the 0, or A estimate is equal to the 0, and then H1 is like our slope is not equal to the 0, the slope of the model. So in a simple linear regression case, this is the same as testing the hypothesis that the variation explained by the model via regression is significantly larger than the error term. So when we want to test this, well, our test statistic, it's F test. So MSR over MSE, when you are looking at your ANOVA table, you will see that MSR over MSE, it's your F value, is like F of the observation, right? So that one, like F equal to MSR over MSE, is your test statistic. We would say that always is like this. If your F of the observation, like F of the problem that you have, the F as a result of the ANOVA table, MSR over MSE, if that one is a lot greater than the F of the critical value, that F that you would get from the table, in that case, you would say that you would fail to reject the null hypothesis, or you would reject the null hypothesis. So you would make a conclusion on it. And then when you make a conclusion on it, then you can say that if the overall significance of the regression test is going to help you or not. One way is that one. Another way is that you would say, okay, so let's find an equivalent to it. And the equivalent for the overall significance of the regression, we can say, okay, so let's say MSR over MSE is equal to 1, which is my null hypothesis. And alternative hypothesis is MSR over MSE is greater than 1. So it's going to be like, it means that MSR, which represent the variance of our regression, it's a lot greater than the variation, or the variance of the error, which is going to be a good thing, right? So here is written MSR is the variance explained by model, and MSE is the variance due to errors, right? And we said that in the previous video when we were talking about the analysis of variance, we said that, okay, it's the same as the sigma to estimate. MSE is the same as the sigma to estimate. So what type of test is this? We already talked about that. It's the F test, right? MSR over like MSE, this is F test. So we can compare it with the whatever we get from the F observed. We are going to compare it with the F critical, and then we would say we want to accept the null we would reject the null hypothesis, or we fail to reject the null hypothesis. Be careful here. Here, the null hypothesis, we want to reject the null hypothesis, right? And so it's very important that our F observed be really greater than the F of the critical. It's and when you look at it here as well, it's like that here H1 is the one that is the good one. So we want to reject the null hypothesis. And we said that the power of the hypothesis testing is that when we want to reject the null hypothesis, we are going to set it in a way that we would reject the null hypothesis and we are going to reach our result. So let's look at the next one. To test the hypothesis, by whatever I said is written here, we compare the ratio of MSR over MSE to the F distribution. F distribution it means that F from the table. If MSR over MSE is greater than F of these degree of freedom, like the degree of freedom of the regression model and degree of freedom of the error, because we need to, when we say F from the table, we need to, if we were comparing two different variances, we would have two different sample size and we would have two different degree of freedoms. But here we are talking about the regression model. Have you thought about it? That, okay, so when I want to, Lena said a few times that, okay, so we are going to read the F from table, but with what degree of freedom? Like, what are going to be our degree of freedoms? So the degree of freedoms here, it's going to be when you want to read the F from the table. It's going to be the degree of freedom of your regression model and your error. Degree of freedom of a regression model is the number of the parameters. Like, for example, here I have two parameters, A and B, -1, right? That's going to be my degree of freedom of the regression model. And then degree of freedom of the error, and degree of freedom error is going to be n, whatever number of observations that you have, minus number of the parameters that you would have. So if you have like 50 data points, it's going to be 50 minus, for this simple linear regression, we have two parameters, so -2. It's going to be like 48. So when we read the F from the table, then we are in the rejection region of the null hypothesis if this one is greater, right? So we would say that we reject the null hypothesis. And remember this, if the model is significant, the model explains a measured amount of variability in the data, so it is a good model. So it's like that, we would say that if we reject the null hypothesis, it's a good thing here. So we want to reject the null hypothesis to say that, okay, so at least we have one A that is not like a slope, that is not equal to 0. So my model is working.